Do you have this?
I don't need this. I don't need it. I need to hear.
No,
Okay, what's right there? I mean, I think create. Who is missing now? Well, anyway, okay. So again, to simplify, this is what I have. Okay, now let's talk about a new function, the average physical product. So again, I find the maximum y by setting marginal physical products equal to 0, which is the same as the derivative of, no, it's d. D of y divided by d of x equals 0. Okay, that's give me a function. So that's usually gives me a function. Okay, and yeah. So the maximum here is there. The maximum here is there. Inflection points. Increasing return to scale, decreasing return to scale. All right. Now, these are the information that I can obtain from the average physical product, marginal physical product. Now, what about the average physical product? So we know that is y divided by x. Okay, clean. So the average, of course, averages the marginals, right? So if from here, let's say I have 2 to 4, that's 2. And then since it's increasing, then I get 7, okay, that's 3. Well, the average is going to take the average of 2. So the increase from here to here going to tell me, well, is 2.5. I got 2 first and then 3 first. On average, I get 2.5, right? Okay, so that gives me, well, okay, on average, what is this cow give me additional on average as I'm increasing my input as I'm feeding her. Okay, and so this average is going to cross my marginal, okay, at this last kind of inflection point here. Okay. And that's where it's going to be, where my profit is going to be. Okay, why? So first, the marginal is, let me write the average physical product. So the average physical product is like this. Okay. So stage 2 start here, okay? This is 2 overall. We have an intermediate stage here that we talk about a lot. So at first, my marginal is higher than my average. what that means really is only that I talked about in class one time. If you think in terms of your grade, right? Um, your first grade is 80, your second grade is 90, your third grade is 95. Okay, and so if you do the average, you get a number, right? But in any case, right, this gap of 10 and 5, okay, the average is going to be is the gap, okay, is less than the average. So, oh, sorry, it's higher than the average. So the change, the margin is going to be higher than the average. And so I'm increasing my grade, and then this is grades, right? I'm increasing my grade because marginally I'm increasing the grade. My average are increasing too. That's wonderful. And when my grades start to decrease, right? So when I'm going from my 90s and I'm in the 80s again and 70s and 60s, right? It's going to push the average to slow down. Does that make sense?
Yes.
Okay, the average is going to slow down to a point where the marginal is going to be below the average, right? So that means that I want to make money, okay, usually on the average. Okay, on the average, that's what I want to make money typically, right? Because why? This is critical because how can I put this? My additional cell, okay, I need to get, so marginal physical products has to be equal or greater or equal than the price of a good. Well, actually the value, right? Okay. So if my marginal product is 3, the price is 2, right? Then if I cannot sell my crop, okay, for more than 6, then obviously I'll be losing money. Does that make sense?
Yes, sir.
Okay. And so when I get down here, when my marginal is below my average, then I am in profitably wise talking, I am in a red zone. But this zone is determined only by the value of P to F of price. Okay, so you can shift and switch depending on what price of input is and price of output is. But these points is what going to be my maximum profit is, but I'll be talking about it in a moment. Okay, so we talk about why average physical products, marginal physical products, and now we will move to cost. So let me clear everything. Okay. Maximum output. Okay. The maximum of the average physical product, because that gives me what information? The maximum of the average physical product giving what type of information? Is the inflection point, okay? No. It's not, it's here. So over here, I will have my maximum average, sorry, over here, average, no. Yes, I think that's, right, yes, that's my average, is not marginal. It's my average physical product, okay? But over here, that's where my marginal physical product is going to be maximum. So it's my marginal physical product is above until it crosses here and go down. This is my marginal physical product. So I can also find, okay, at which point X, my average, let's see, yes, my average physical product is the greatest. Okay, and to find out, what do I do? At this point here, at the maximum of APP, okay, how's the slope? What is the slope like at the maximum of APP here?
It should be 0.
Is 0, right? So to find the maximum APP, well, I say D of APP over D of X equals 0. To find those, for this point A, to find point B, maximum of marginal physical product, and so maximum the the up higher level of marginal physical product, okay, is derivative of marginal physical product over G of X, and that's equal 0. Okay, so when you're asked a question, I have this production function. Let me take a textbook production function. I don't know where it is. What do we have as production function? Which production function do we have? Applications. Anyway, I'll just take my old production function, right? Okay. Y equals x plus 6x squared minus 0.3x cubed, right? And the question is, at which level of x y is at max? Okay, then the answer is when y, the derivative of y is 0, when d of y equal d of x equals 0. Next, which level? Yeah, of x, okay, y is maximum. Question 1, question 2. At which level of x average physical product is max? Well, I said the derivative of average physical product equals 0. That will give me this x here. Okay. And same thing for, so what, the only thing, so the main thing to understand is that it's simple. We are looking for derivatives. Usually you want to know, well, okay, I'm producing, okay, where do I reach the maximum? When do you have a switch from increasing, okay, increasing return to decreasing return? When did that happen? Okay, and then we'll see that here later, where is my highest profit? Okay, so that's the only thing I'm thinking about, right? And so the profit is going to be maximum when what happens? When, I think that's correct, when average physical products equals a marginal physical product.
Oh, shoot.
Okay, when they cross, that means when they are equal. But I don't want to talk about profit now, we'll get to it. So what I want to point out is those optimums, and that's it. And so for everything, we just, take the derivative. So on the production function, we'll be looking at the maximum, okay, that we can get because we want to get as much output as possible. On the cost function, we are looking at the minimum, right? Because when it's costing you something, you want to spend as least as possible. Okay, when you are producing something, you want to produce as much as possible. Okay, so let me clear everything and we move to the cost function. So so my cost function usually looks like so of course we have three different type of costs, right? Total cost equals total fixed cost plus total variable cost. Okay. So if I have my total cost that looks like something like this, and in fact, after that, it will come back here, just like production, okay? This is important actually. Here I have Y and I have dollar amounts because those are costs, okay? So cost is expressed in money. So what I'm trying to figure out, okay, as I'm increasing my output, how much does it cost me to do that? And this will be the optimum, right? And at this stage here, when I have this happening, it means that I'm still spending more money in this area, but I'm getting fewer input, fewer output. Do you see that?
Yes.
So that's what's the full cost function. That's what it is, right? But usually we stop here at the maximum. Okay. Then I have my total. So this is my total costs. This is my total fixed costs, and my total variable costs. I'm going to do this different color. What you see here is that the total variable cost and the total cost, really, they have the same slopes, they have the same shapes, right? Why? Because to get the total variable to the total cost, I only add the total fixed cost, which is fixed, doesn't change. So they really have the same slope, the same shapes. All right. So I have Y, again, here is money. So the question I will have usually, okay, what is the value of Y that's minimizes cost, okay, or at which level of Y my marginal cost is minimum. Okay, so let me try to find a cost example. Okay. So I take a cost function. I start with the average total cost equals 100 minus 3y plus 4y squared. First question, it is what is the average? This is average variable cost, sorry. What is the average variable cost? Oh, correct, right? It's average total cost. Why am I so stupid? Yeah, average total cost. Okay. What is the average variable cost? Equals average cost divided by y. What is the marginal cost? Is equal to change, right, in average total cost divided by change in y, right? And this change here is the same as derivative of average total cost divided by the derivative of y. And we know how to do that, right? And we take the derivative. So the derivative of this is going to be minus 3 plus 8x, 8y. So knowing that, I can find out, well, at which level of x or y, okay, my marginal cost is the lowest. What do? I said the derivative of marginal cost, d of y, equals 0. So I will set minus 3 plus 8y equals 0. That is 8y equals 3, and y equals 3 divided by 8. That should be the minimum level, okay, where I will have my marginal cost. My marginal cost will be at the lowest here when y equals 3 divided by 8. Okay, and the same thing, if I'm asked what, at which level of x is, where am I going to put my average variable cost now? Average marginal cost is here, my average variable cost is going to be, this doesn't show. I think it should be like this. It should be, well, this is my marginal cost, and this is my average variable cost. This is the average variable cost, sorry. Okay. So marginal cost will be at the minimum here, the average variable cost will be at the minimum here, right? And so the same thing, if I'm looking for the point at which my average total, my average variable cost is minimum, I will take the average variable cost, which is here, it's minus 3 plus 4y. And that's going to be equal to 3 divided by 4. Average total cost. So you can see that the average total cost, the point where the average total cost is at the minimum here, is greater. So this is 3/4 than this minimum of the marginal cost, which is 3 divided by 8. Let's make it a little bit more clear here. 3/4, and this point y is 3 divided by 8. Okay. And so that's what we see here, right? First, I will have the marginal cost that will go down and up. And the opposite is this, is a marginal product. And the marginal product looks like what? It looks like this, right?
Okay.
The exact opposite. And so the maximum here is this. But here I have x, a function of x. So when my marginal is increasing, if I'm getting more and more, that means it's it's costing me less and less in input, right? And my cost start increasing when my return start decreasing. So it's very, very logical, right? Okay. So the opposite of marginal product is marginal cost. So marginal cost says, so here I have increasing return to scale and then decreasing return to scale. Increasing return to scale and then decreasing return to scale over here. Okay. So you have plenty of questions like, what is average total cost when Y equals 4? And so you just plug in. Okay. That good? It's clear?
Yeah.
You're not sure? I mean,
No,
everything
makes
like
it
clear on
makes
the spot, okay?
makes sense. Yeah.
If you go back to it, then of course, you'll see that is more clear. Okay. So I'm going to clear everything up and we'll talk about the profit function. So I'll start here. X, Y here. So the profits is a function of, will be a function of Y, X. Okay. Okay. So for profit, we are really looking at two things. This is just like before. Okay, well, this is a different concept, new concept. The first new concept is, well, this we know, right? Profit equals total revenue minus total cost. Visually, you split it up. So what total revenue is price of output times output minus total fixed cost minus total variable cost, right? And we can also write it as, so PY, Y, minus PX, X, that's my variable cost, okay? Minus total fixed cost, right? So my revenue is this, and this is my cost. Okay, so PX, of course, is PX equals input price, and PY equals output price. Okay, so of course, PX times Y, right, is my revenue. This is my cost. And so the total revenue is the same as what we call value. Value product. Okay. We don't call it value cost. I don't know why, but value product. And so this is, and so the value marginal product. So what is the value marginal product? Okay. Is the derivative X, right? The derivative of a value marginal cost. And so, so the value marginal product, or is going to be, so PY times the marginal physical product. Okay. because yes, yes, or revenue, because oops, I only have 10 minutes left. Okay. So this is my PX, right? So where am I going to be at the optimum of profit? My profit is going to be at the maximum over here. Okay. When value marginal product equal PX. What does that mean? The value marginal product is revenue increase per units of additional output. Output. Okay, so this is when I sell one more unit, right? I'm going to get this value here. Okay, I'm going to get the price of that unit, well, times the quantity of the additional Y that I produce. That is my value marginal product. What I get in by selling one unit, one additional unit of output, cannot be less than what is costing me to produce that additional unit. I repeat, what I'm getting in the value marginal product at the optimum here, this is a profit function, cannot be less than what is costing me to produce that additional unit. That's why this equality between value marginal product, so it's value marginal product, right, equals input cost is the optimum. And this is my profit function. So my profit is at the maximum when every time I'm selling one more unit, it costs me less, okay, than the revenue I get from selling that unit. Does that make sense? Every time I'm selling one more unit, so let's say milk, right? The price of milk is $2 per liter, okay, okay, and the price of feed equals 3. So what I'm looking at is if I add, okay, if I spend $3 in input, I want the price of of X, and so it's 2. Okay, I want 2 times the additional output that I get from spending more $3. Does that make sense? If by spending $3, I get only one input, one additional output, so I say 1. And so here, I'll be spending $3, but my revenue will be $2. Do I want to produce there? If I get $3, if I spend $3 and get a revenue of $2, is that good or bad?
You don't want that.
You don't want that, right? And so you want that what you are spending, the $3 you are spending, the PX, okay, yield at least as much as you spend. That's why at the optimal of profit, okay, we need to have price of X equals value marginal profit, value marginal product, because value marginal product is just money that I get from selling one additional unit. Okay, or my marginal revenue. And price is my marginal cost, right? PX is my marginal cost. So the same thing like marginal revenue equals marginal cost. Okay. So yes, go ahead.
Just a quick question.
Yes.
In terms of agricultural, in terms of an agricultural standpoint, how does this work whenever prices of commodities could fluctuate week to week so drastically?
Yeah.
That's why agriculture is one of the most difficult business that exists on earth. Right. That's the reason why farmers need to know in advance, okay, what this PY is, because you can see that this PY what fluctuate over time. And if they don't know this PY, they cannot know how much input they should, add to the soil to get the output.
Right.
Because if you say, well, okay, I want to increase my yields, okay, and I want high yields, and you put a lot of input, right, to a point where you're at the maximum. That means that you are spending a lot of money to get a small marginal additional. Well, if you don't know what the price of output is, you cannot make that decision.
Right.
You cannot, right? And that's the reason why, to mitigate risk, farmers sell in advance before they start producing a part of their output. We say, okay, now I know that half of my inputs, my value marginal product is going to be this. Therefore, I know my production function. They know their production function, okay? Farmers know their production function. They know their land, they know their soil. They know how much output they get on average by increasing input. Even milk producers know that. By experience, you have that instinct. You know that. So you know your production function. So to decide how much input I want to add, well, I have to have a price. Otherwise, I cannot make a good decision. That's why the future price in agriculture is so important. And that's why, many farmers prefer to lock in some of the output before they make their decision, because they can make a profitable decision.
Yeah, contracts.
Okay, and it's all here.
And so once they lock that in, say that crop doesn't produce what they think it's going to produce for that certain year, how does that work out? Is that crop insurance then going into that?
That's why we have crop insurance.
Okay.
Right, but no insurance, and that's what we'll be talking about in the ag policy class this summer. Okay, we talk about crop insurance because it's so critically important, and we see how and why policy-wise very important. I mean, it has to be government that set up a crop insurance, and we'll talk about it a little bit more. Okay. So if you guys want, I can have this meeting again tomorrow. Okay, so what I suggest that go ahead and try to do your homework now.
Yes.
Read the chapter that is posted, chapter 3.
Yes.
Okay, and tomorrow we have this meeting again at 10 o'clock.
Sounds perfect, actually.
And we'll go through any difficulty that you may have. But if you take the time to watch some of the videos, they will help you too.
Okay.
What you're
Sounds
trying to do is
perfect.
not difficult. Just find your optimums, and that's it. Okay?
Okay, sounds perfect,
All right.
doctor. Are you gonna post all the information later on, like the
Yes,
meeting?
I will post this video too.
Okay, sounds
Okay.
perfect.
All right, video. And prepare your questions, okay?
Mm-hmm.
prepare
Thank
your
you.
questions for tomorrow, okay?
Okay. Thank you, sir.
All right. See you.